More than half a century has passed since humanity first reached the lunar surface. After Neil Armstrong's historic words on July 20, 1969, our natural satellite remained beyond the reach of human footsteps. Today, NASA launches the massive Artemis Program, aimed not at simply repeating past achievements, but at establishing a long-term human presence on the Moon. The program's name carries deep symbolism. In ancient Greek mythology, Artemis was the goddess of the hunt and protector of the Moon, as well as Apollo's twin sister. This connection emphasizes the continuity between Apollo's achievements and modern aspirations. Each launch within the program presents a magnificent spectacle. A giant rocket, exceeding a 30-story building in height, soars into the sky with power sufficient to lift cargo weighing as much as 20 elephants. The fiery streams of engines stretch for kilometers, while the Earth trembles from incredible force. At the heart of the program lies the Space Launch System SLS rocket, a true embodiment of modern engineering thought. This 98-meter construction represents one of the most impressive aircraft in human history, but the imposing dimensions merely reflect its true capabilities. SLS's ability to deliver 27 tons of cargo to the Moon equals transporting 6 adult elephants. Such characteristics create unprecedented prospects for delivering scientific equipment, materials, and all components of future lunar infrastructure. The power plant includes 4 main IS-25 engines combined with 2 solid rocket boosters. Together, they create a starting thrust of 8.8 million pounds, exceeding the legendary Saturn V's power by 15%. Crowning this colossal rocket is the Orion spacecraft, a revolutionary means of astronaut transportation. Unlike its Apollo-era predecessors, the modern vehicle possesses expanded capabilities and improved safety systems. A 4-person crew can remain in autonomous spaceflight for up to 21 days. The spacecraft is equipped with advanced life support, radiation protection, and navigation systems. The heat shield withstands temperatures up to 7 OC when entering Earth's atmosphere at escape velocity. Safety is ensured by the launch abort system, capable of instantly pulling the crew capsule away from a potentially dangerous launch vehicle. An innovative component of the program is the Gateway Orbital Station, the first habitable station in deep space. Unlike the ISS orbiting Earth, Gateway will function in lunar orbit, serving as a transit hub between our planet and the lunar surface. The station will occupy a position on the near rectilinear halo orbit, a highly elliptical orbit guaranteeing stability in the Earth-Moon system's gravitational field and continuous communication with Earth. Astronauts will use Gateway for landing preparations, conducting research, and long-term space studies. To reach the lunar surface, NASA established a partnership with SpaceX, selecting their revolutionary Starship human landing system. This 50-meter spacecraft fundamentally differs from the compact lunar modules of the past. Starship HLS's payload capacity exceeds 100 tons, tens of times greater than Apollo vehicles' capabilities. Such parameters allow transporting large scientific equipment, construction materials, and everything necessary for a permanent lunar base. A unique feature of the system is orbital refueling. Several tanker starships will transfer fuel to the lunar variant in Earth orbit, providing sufficient reserves for the complete mission cycle. November 16, 2022, marked the historic launch of Artemis I, the first unmanned test of the SLS Orion system. The rocket successfully directed the spacecraft toward the Moon, opening a new chapter in lunar exploration. The 25-day mission included a lunar flyby with minimum approach to the surface at 120 kilometers. Orion tested all critical systems in deep space conditions, thermal protection, navigation, and life support. Images transmitted from the spacecraft held special value. Orion's cameras captured stunning views of Earth and the Moon, reminding humanity of the beauty of cosmic space. The next stage, Artemis II mission, planned for 2025, will be the first crewed flight to the Moon in more than 5 decades. For astronauts will perform a lunar flyby without landing on the surface. The 10-day expedition, several days of which will pass in lunar space, will allow testing all Orion systems with crew aboard. The astronauts will lay the foundation for subsequent landing missions. The flight's historical significance is emphasized by the participation of the first woman heading to the moon, demonstrating NASA's commitment to diversity in space exploration. The culmination of the program's first phase will be Artemis III in 2026, the moment of humanity's return to the lunar surface after more than a half-century hiatus. For astronauts will head to Gateway Station, where two will transfer to Starship HLS for descent. For the first time in history, a woman will step onto the lunar surface, symbolizing a new era of space exploration. The week-long stay on the moon will significantly exceed the maximum duration of Apollo mission's 3 days. During this time, extensive scientific experiments, soil sample collection, and testing of technologies for a permanent base are planned. The program pursues large-scale scientific goals extending beyond simple return. The primary priority is searching for water ice in the moon's polar regions. Discovery of substantial water reserves will open exceptional opportunities for sustainable lunar presence. Lunar water is valuable not only as a drinking source. Its decomposition into hydrogen and oxygen will enable rocket fuel production directly on the satellite, revolutionizing spaceflight economics. Geological research will help understand the solar system's formation history. The lunar surface preserved imprints of ancient cosmic events that disappeared on Earth under atmospheric and tectonic activity influence. The program stimulates breakthrough technology development. Particularly important is in situ resource utilization (IS) technology, enabling oxygen extraction from lunar soil, construction material production, and fuel creation. New exploration extravehicular mobility unit spacesuits will provide unprecedented mobility on the lunar surface. They will allow working up to 8 hours continuously and provide protection from lunar dust that created problems for Apollo. Artemis unites efforts of more than 20 countries within the Artemis Accords framework. Participants include Japan, Canada, Australia, the United Kingdom, and many other states, each contributing uniquely. The European Space Agency creates the service module for Orion. Japan develops a lunar rover. Canada provides the robotic arm for Gateway. International partnership makes the program a truly global human project. The program forms a new space economy worth tens of billions of dollars, stimulating the private space industry, creating high-tech jobs, and advancing cutting-edge technologies. Many lunar developments will find terrestrial applications, life support systems, new materials, energy technologies will benefit far beyond the space industry. The moon is viewed as a training ground for Martian missions. Experience in creating and maintaining a lunar base will prepare humanity for the journey to the Red Planet. ISU technologies, closed-loop life support systems, radiation protection methods, all Artemis developments will become the foundation for Martian expeditions. Despite achievements, the program faces serious challenges. Technical complexities, budget constraints, and political changes may affect the implementation schedule. Creating reliable systems for extreme lunar conditions requires thorough testing and multiple verifications, which is always associated with uncertainty. Artemis represents not merely a return to the moon, but the first step toward transforming humanity into an interplanetary civilization. Lunar experience will become the foundation for exploring the entire solar system, a future where spacecraft regularly travel between Earth and the moon, where scientific stations and industrial complexes operate on the satellite, is becoming reality. Humanity prepares to use cosmic resources for its development. Each launch, experiment, and astronaut step on the lunar surface brings this amazing future closer. We are witnesses to an era when humanity's cosmic dreams transform into reality.